All right, now the fun part, software. So I'll let you know I've set myself up for quite a many failure on this machine. This is the worst computer in the world. It's Windows on a Mac. The USB is always suspect when that happens. So I picked this machine for a good reason. This is worst case scenario, so I'll show you how to get that working. First thing you're going to need is your Arduino software. Okay. So we want the Windows 7. Just download. Unless you want to, I would wait a few weeks after you play with it to understand the contribution level there. For those individuals that are doing this one and done, never touch it again. Or you could be like, whoa, what's this? What does this thing do? All right, so get that downloaded. There we go. So we double click on it and install it. All right, so it's going to come to this right here. Would you like to install this device software? Yes. Install. Install everything. Install. All right, sweet. Then close that out. All right, now we have to look up something. ESP32 Arduino. All right, there's going to come to this ESP core for ESP32 at GitHub. You're going to look down and there is going to be installing. All right, so what you need is this stable release link. So you grab that and then you open up this new program called Arduino. Hit allow. All right, so that little string goes into preferences and you put additional boards and URLs. You paste it right here and hit OK. Okay, with that in place, you can now go to Manage Libraries. Oh, actually, let's go to Boards first. Let's go to Boards and go to Boards Manager. And we're going to type in ESP32. Right there, that one pops up and we're going to install it. It's rather big. I'm probably going to cut this out of the video. You probably don't even hear me talking right now. All right, now that that's installed, we can close that out. And most likely, this will be grayed out for some reason. So first we're going to go and pick our Arduino. It is the ESP32 dev module. Notice the port is still grayed out. Okay. Now that's because I said I set myself up for failure on this machine, And I chose this machine because that is a core indication or problem with some machines out there with any Arduino project is the fact that you can't get to the port. So I will show you how to fix that. All right, so the first thing we're going to do is plug my PlayStation 4 cable instead of this one. This one right here, I just randomly found, and I thought it'd be a great set myself up for failure type of deal. So here's my PlayStation 4. I heard a ding there. Did you hear that? It was like ding, and so when I heard the ding, now notice port lights up and the COM3 lights up. So when I first did that a long time ago, it took me days realizing that it was just the wrong cable. So there is setting yourself up for failure, and there's how you fix it. You choose the right cable. Send and receive cable, not a charging cable. If you want to see what the other cable looked like, it was this little tiny thing. And we have these laying around all over the place. At least I do. It's this little tiny cord. Looks exactly the same. There's the USB micro or mini. And yep. Garbage. Okay, recenter all of this good stuff on video. So now we have connection. And now I'm going to show you how to program it. I'm going to show you the code that I wrote for it, and how to augment the code a little bit in case you want to play. That's going to be in this next part. All right, now we're going to look at the code. I'm going to share the code via a Google Doc. It's labeled V1. So what's going to happen is if there's a version 2, a version 3, you can just get that along with the additions. If you ever want an older version, you can just go to see version history and you can get older versions that way. And maybe I'll put that at the top too, like that. All right, cool. So now that'll change along with the title and match. All right, so let's go through this code. First off, in Arduino, we just go File, New. And you can just blank all this out, delete it. Then go back to the Google Doc and copy everything. Make sure that you go all the way down. Copy it. Go over to your blank Arduino sketch and paste it. Yeah, there we go. All right, let's go over things that this does and what you can change and what you can't. Okay, first off, what I got is this reads something 20 times, okay? Now you could change this number, a different number for readings, but in this case, I would like to sample the sample 20 times, okay? And that happens very quickly, like within a matter of seconds, it reads it 20 times. So you don't even realize that it's doing it 20 times. Then what it's going to do, it's going to use that 20 down here in this calculation. It's going to loop it, okay? So the above part right here is things that happen when it first starts up. And then it'll go into a loop and forever be in a loop. So things that could change up above is the number of readings, if you want to shorten that and play around with it. The input pin can change. Let's say, for example, you bought the ESP32. It had, I'll just click on a random one. Hopefully it has a pinout. Yes, it does have a pinout. So let's say instead of ESP, or that one right there where it says GPIO34. So, and it's right around this area. I can't mouse over here, but where it says GPIO 34. Maybe I wanted to use 35 instead. I could, and that is what that number is right here. This is the pin of the ESP32. Right now I'm using 34, but you can use, there was a ton of them on that. You can see it all the way here from 36 all the way down to 25. Oh, no, 12. Yeah. So all of these green ones can happen, and these are the numbers that you would choose if you wanted to use the green ones. All right. The other part is this is the speed at which I'm reading it. I wouldn't change that. That's why I picked the ESP32, because it can handle like that 20 times sampling and then some. This could go up to probably 1,000 and it still handle that. And I just slowed it down to 1,000 just so the window can keep up with the readings and your mind can keep up with the readings. This is important. This is basically setting everything to 0 anytime it starts up. So the loop happens like this. It says total equals the total minus the readings. Okay, reading index is 0. It starts out with. It waits to 20, and then it does its calculation. It uses an array to do this. This stuff I would not mess with at all. It would not be advisable. So down below, here it's taking the average. It's making an average based upon the total divided by the number of readings. Then I have to remap this back because right now it's mapped to between 4096 and 0. So it goes from 40. Oh, it used to go. It goes backwards with the reading. So in order to be able to chart this stuff, I can't have a chartable index of 4096. It wouldn't be really easy to chart. So it doesn't really matter what number spits out as long as it's chartable. So what I did is I took it to, so it's backwards from that. If you ever want to just play around with it, just switch these two numbers and see what it does. Put 0 here and 4096 here, and you'll see exactly what I mean. I would leave it divided by 100. It allows this average to float instead of being a whole number. And then if you are really old and have a hard time understanding things at a very fast pace, you can change this to maybe 5,000. And that will slow the feed down. So what we're going to do is we're going to write this little code onto port COM3. Remember, I chose the ESP Arduino ESP Dev 32 module. If you have something else that you bought from, there's a list, but if you are at all lost, just use this one. All right, cool. This is the right button. It wants me to save it somewhere. Save it to my desktop, even though I don't want to do that. Over here in the ESP cam, if it's still going, you're not going to see very much as you translate it over. Might see that light blink. Hard resetting RTS pin. So now it's written on there. When you see the hard resetting via RTS pin, it's good to go. So we can look at the serial monitor and then switch this baud to 115K. There we go. We have numbers. Yay. So what this does right here, let me make sure that this is all going correctly in the capture window. Good. You can see my hand here. All right. And let's go back to the serial monitor. So let's pretend for a second I just changed this. I rotate it this way. It. Oh, there we go. See how when I rotate it, it now picks up 0.7. So 0.2, we're gonna treat that as 0. Okay, 0.2 is if I go all the way to the right or left, depending on how you hook this up. If you hook the ground on this side, it rotates this way to 0. If you put the ground or on this side, it would rotate this way. Doesn't really matter. What you have to do is rotate it all the way to one side, and you'll see 0.2. That's an indication of 0. The furthest it can get with the average. Pretty darn small. And we know it works because as I rotate this, we can see a number change eventually. It's got to go 20 intervals before you see a change. So just because you change it doesn't mean you're going to see it right away. If you want to speed it up, you could change your number of readings to 4, and that way you can calibrate it. There we go, right there. Okay, sweet. 0.6, 0.7. All right, now we're ready to read a sample and plot it out. So I gotta go get my samples. All right, so just know that if you do choose the box method, you would have to have this switch outside the box when you went to zero it out. I am not at all upset with the results based upon it never being covered up. And it's because I'm in infrared zone, okay? So the infrared light coming off that LED is way different than the ambient light around me. There's barely any infrared lights around where I'm at right now, so it can't get too botched up, okay? So just know that if you do cover it up, you would have to have this potentiometer on the outside of the box to make the adjustments like I'm going to be showing you. I am totally happy with the curve it's making right now, and I'll show you how to first zero it out and then plot it out. Okay, so right now I would have to start out with distilled water. Okay, and I need to zero out the unit. So I'll put the distilled water in it. Okay, then we're going to go over to our plot or our serial window, and we're going to let it settle. And you see how it just turned to 0.02. 0.02 is 0 on this unit, okay? We'll never get down to 0 because of the average, unfortunately. That's just the math. Now, if you go and rotate this, okay, what you want to do is rotate it 1/1000th of an inch in one direction, depending upon which wire's on which side. Since I had the ground wire on this side and the red wire on the other side, I can rotate it clockwise to bring it up into increments. What I want to do is rotate it 1/1000th of an inch, count to about 10, and see how it just turned to 0.03. I'm on the threshold right now. That's where I need to be. Now I need to back it back down until it says 0.02. And that is my threshold of being on 0. Okay, so I'm going to change it again. I'm going to try to get back to 0.02. And I'm trying to be on the very threshold of 0.02 and 0.03. Do you need to be that accurate? Nope. Again, these are plottable points as it goes. I can dictate what 0 is because I'm never going to touch this dial ever again, ever again, unless I decide to go all black, or if I decide to go outside and use the unit where there's more infrared light. Once I make this change, I'm never going to use this dial ever again. So it's just on the cusp of going to 0, 2, and it's only my OCD driving me right now. There we go. Okay, I'm gonna leave it. So that is now zeroed out. Get rid of my distilled water. And that's how you zero out the unit. All right, now we're going to look at how to make readings. To do that, I like to have an Excel sheet open. Okay, an Excel or Google Excel sheet. So if you go to drive.google.com and just go click on New Sheet, blank spreadsheet. Here is my concentration levels that I have available. I have 0. I have an unknown, which we're going to look at. I have a 1.25. I have a 0.5. So I have 4 levels of measurement, believe it or not, because 0 counts as a measurement. So what would be the absorption ratio based upon this 0? Well, technically, I could say 0.02. Okay, if I wanted to be a completionist. Okay, that's our 0. Okay. So we go to the 0.5. I'm going to slide it between here. Make sure it's all wiped off, and make sure that the 2 units are in parallel with each other. The light is touching the glass, the cell is touching the glass, and the light is going through a good angle like that. Okay. All right, I'm going to go back over to our window, and we're going to just let that settle. Let it settle. So based upon it's taking 20 samples, then it's, I can see it's starting to level out. So it's between 90 and 91. So 0.90 or the 0.5. Boom. All right, let's take another sample. And where's my 1? It's driving me crazy where all these samples are. Ah, here it is. Imagine like walking into somebody's house and there's just like all these like weird blue sample things laying around. All right, so just let it settle. Okay, it's going back up, going back. So 2.34 I'm going to choose. Eventually, you're just going to have to pick a number. Okay, that was for the 1 molar. Okay, let's go to the 1.25. Go. 2.77. Cool. All right, so let's take these. Boom, boom. We're going to go and make this into a chart that we can use. Chart. I want to have a line chart. Look at that beautiful curve. Oh, so good. Bear Lambert would be so proud. So I'm going to go to Customize. I'm going to go to Series, and I'm going to choose this point size to be 10 points. So these are my sample points. And here's one I did earlier in complete darkness. You can see it's got the same curve. Okay? It's a linear curve. You can see that it changed my result a little bit. So all I would have to do is pledge the rest of my life to always do testing in this one spot. Okay, to get those results, to have it match that curve. If I did it in complete darkness, I can be anywhere in the world in any lighting because it would be in a box. That's the difference. Okay, so whether you want to do it in a box or do it in your lab in a very certain area, in a very certain lighting condition, doesn't really matter. That's the difference. Okay, so we have a sample, a random sample. Now we can use that random sample. We can take as many random samples as we want because we got this curve. It would be nice to have a little bit more points on our curve to make it a little bit more accurate, but it's always going to be linear, so it doesn't really matter. So the results are always going to be within this range that we're kind of lost in, okay? And just to give you some introspect, I did put on this curve. So right here at 1 molar, I'm at 24.96. So between, it's usually 22 grams is the magic number that what we want. 22 grams is the standard that I go by anyway for the concentration level. Okay? At 22, it acts nice. Anytime it gets up into 26 or 30, that's when it just falls to pieces. So let's look at our random sample. So right here, this one value, right here is where it's good in this case. And right here is where it starts falling apart. This is the good zone. Okay? Good zone. Anything outside the good zone? Pink fill. So random sample, this one is taken by a tank that is completely salmon. Need to decide what I want to do with it. So let's find out based upon our ESP32 what I need to do. And it settled for about 1.60. Okay, 1.60. And that would be right here. And we're right here is where we want to be. Isn't that cool? Now I know. Okay, it is got too much copper in it by a little much, but not bad, right? It's right on the cusp, right in this area is where it's good. Right here is where it's at on the curve, around this area. And I can use this curve to make decisions now. I can say, well, I could empty a little bit and add water to it. Okay, that's one way to do it. I could stick to a graphite anode and a graphite cathode in and apply a small voltage to it, and I can suck some of the copper out that way to reduce the level of copper. but either add water or use graphite anode and a graphite cathode. I now have a choice. So when does it get pink the other way? I would say right about here. About 0.75 is when it starts going pink the other way. In fact, it's a different type of like bad. It's like this ball bearing type of deal where it has like these super weird balls that grow on all the thin parts of the copper. So it's not pink. It's a different type of bad. I don't have a sample to show you. I don't ever go this way very often as far as the reduction. But trust me when I say, you know, like right around in this area, you're going to have some problems too. And then how do you fix that? Well, you let your tank dehydrate. That's it. You let your tank dehydrate, and then your concentrations level goes up because your water's out of it, and then you go back to normal. And you can decide, well, do I want to take a sample of that and see where I'm at, and then run the bath. Another thing you could do is take and make sure that let's say you had the awesome bath, right? The bath that's just like, oh, it's running at ideal situations. Now you can, before you, celebrate, you can take a sample of that really good bath and then apply it to your curve, and it shows where you're at. All right, so that's how the curve works. So I kind of just labeled this area as good. You're missing a little in-between area right here that is going to be at the 22 gram level. So here's how you add some of this stuff in here, just in case you're interested. All you need to know is the weight, molecular weight of copper sulfate pentahydrate, and you need to know your concentration. So you can do this for all your concentrations. You do this in the Google Sheet. You can just go sum, and then you go this field, concentration. Then you go star, so asterisk, 0.1, then asterisk, and then the molecular weight, which is 249.68. And this one's 0, but you can copy this using Control C and go like this and paste it. There we go. I just labeled this green by just highlighting this area like that. And that's a safe place to be. I would say, again, 22, between 22 and 24 is a safe place to be. All right, so I decided to cover the box variation of this because I know I'll have questions about that, and why not just cover it, right? So, for example, if you want to take a reading and you are in the middle of the afternoon, it's bright outside, the sun is shining in the window, and you decide to some way take a reading of your bath, the inside of this box is black, okay, dark. Okay? If it's 12 a.m. and it's dark out, but you have some kind of rave light going on, you shut this, it's dark. Okay, not to mansplain it to death, but I would say that it's always a known variable that it is dark in the box. Okay, so no other light is going to interfere with it, no matter what wavelength, no matter what. Okay, so that's why I'm going to cover the box variation. The only difference in the box variation is the potentiometer is mounted on the outside of the box. Okay, because when you zero it out, you want to zero it out when the box is closed, and you wouldn't be able to hold the potentiometer if it's, yeah, you get the idea. So you want to make the adjustments. So you need to run 3 wires to it, meaning that you would have to have 1, 2, and a 3 micro mother or breadboards. Cool. Or you can have a regular breadboard out the outside too, but you need a lot of breadboards to do it. So I'm going to run you through all the wires, what changed, and I'm going to just slowly do that. And even if they haven't changed, I'm going to run it through anyway. So I have my ground going to the ground of the LED. So that's the short lead of the LED. I have the positive running to the positive rail. Okay. So that hasn't changed. This is running to the 3-volt channel on the microcontroller. And that powers that entire rail. I have the power, 3 volts, running to one side of the photocell. Doesn't matter what side it goes to. Okay. I have my data cable. So I have 3 in here. I have the green, the photocell, and my data cable. The data cable goes into D34. Boom. The green actually goes to the center of my potentiometer. Yeah. Cool. And then I got this ground that powers this entire ground rail hooked up to the ground here. The other ground is going to my potentiometer. Again, just to cover this again, we got 3 volts running to this rail. Boom. And I have the other 3 volts going to my potentiometer. I've been a victim of too many breadboard tutorials when I was younger to know that you have to cover every angle on these things, because you never see. Some people try to like match up the numbers. I used to do that when I was a kid. I was like, be like, well, he has it plugged into N22, and that means it's gonna work. But that's not the case. Just know that all these are connected, all these are connected, and then every row is connected like this. And you're going to be set. You can move it all around anywhere you want to go. All right, so now that I have all that, I can zero out the device and just do or repeat the same process. I would put in my distilled water like that. I would close the lid like that. I don't have anything. I'll put the Shiva stone on top of it because it's just laying around. Why not? Don't even look it up. It's well grounded now. All right, so now we'll look at like zeroing it out. What's the difference? All right, so here I have my readings coming in. So right now it's actually 0 on the COM port, but I want to make sure that it's on the very threshold of 0. So what I'm going to do is rotate this slightly, then patiently wait for 0.3 to show up. Super patiently waiting. Okay. Not showing up. Making a microscope skosh adjustment here. Waiting for 0.3. No signs of life. Okay. Rotating again. Just fight the urge of making a huge change. But by the way, this potentiometer is a 10K. I looked it up. If you are at all interested, here's it in the video that my hand's showing that I'm rotating it. I don't know if that's important. Rotating it again. There we go. Beautiful. So I just got life, 0.4. So I'm going to back it down. very slowly so I can get back to the 0.2, but that's going to be on the threshold of where I need to be. This is where an auto-tuning algorithm comes into play. All right, there we go. 0.2. It's just on the verge. All right, sweet. So I'm going to leave it right there. I'll never have to make that adjustment again. And now I can run through the exact same test I did before, knowing that that curve will be the curve I use forever and always, and I don't have to do all the testing again. So that's why I wanted to do the box variation with you, because it'll be a super stable curve for you, so you don't have to do the retesting every time, even though it is fun. Yeah. All right, so after running the tests, I got these results right here. As predicted, there was so minute changes. The only change was probably at the 0.5 concentration, of a significant change there. But other than that, there was no significant change. So I'll plot this curve for you. Series. Here's my point size. It's bigger. We'll move it out of the way. All right, so there it is. You can definitely see the difference right here. This was like way down there before. But same linear curve showing me that the test is actually working. There was no significant change when it came down to the absolute darkness versus the absolute light, only because I'm in an area right now that is fluorescent lighting. There is no infrared type of light anywhere in the room that I know of, and that's probably why. So good times. Good times. All right. That was fun. Now we're going to look at some other material. All right. So now I shamelessly promote. So I like to keep this information free. The device I just shared with you. I hope you enjoyed it. To make it and keep it free, I do have to promote my other non-free things just to kind of like, to better the research and development for later projects. So I do have a couple courses for you. It is the beginner electroforming setup and the advanced. These links are in the last link in YouTube, where it says Electroforming School. This one has a couple free lessons in it, and it covers, how to make solution, how to set up your lab in a safe way, everything that you would need. Even if you're a vet, it's a good course. I would say definitely if you are buying your own solution from like Rio Grande, stop doing that. And yeah, hop on this window because you can make all kinds of cool things that are inexpensive. And that way, when you do sell them, you profit more. The advanced electroforming is all about organics and put copper on wood, leaves, plants, all kinds of crazy stuff. So this is a very good course, but I would highly recommend you watch the beginner before you get to the advanced. That's for sure. You'll be lost if you just went into here. So now that we have a little device that allows us to measure copper sulfate, like in this course, I do cover something like, like how to do that, but not nearly as cool as spectrometer. But it's because of these, like you're able to or allow me to go into really cool fringe products that, you know, like would better the overall hobby in the long run and share that information out with the general public. And I totally appreciate that. Thank you so much for your contributions. All right. So have a good one, and put anything in the comments below. Maybe if you dress up this thing, you know, like if it doesn't look like this anymore, if you put it in a box or put it in a cabinet or make a hard-coded version of it, share a JPEG in the links below. That would be sweet. But until then, have a good one.